In this video, we'll take up the homework on modeling periodic behavior. So the first question is pretty straightforward. There's really not much for me to say about it, but I will add the fact that for question 1F, I really wish I changed the question because it says within the first 10 seconds, at which times is propeller at a depth of 3 meters. I prefer if it was like first 20 seconds, because if it was first 20 seconds, we'll have multiple solutions instead of just one solution, which occurs at 9 seconds. But it's a minor detail. For question 2, you probably got the same answer as I did, but I do want to mention the fact that we're making a pretty big assumption about Chantel's movement. So if you draw the graph, okay, you plot the maximum point, and then you plot the minimum point, and then you connect the dots, and basically you probably drew half the cycle. Okay, you drew half a cycle of the sinusoidal function. But if you think about it, Chantel can swing a little faster. Chantel can swing, in fact, Chantel could swing really, really fast. I don't know. Okay, but you can draw, yes, you can draw half a cycle, but you can draw 1.5 cycles and still connect this maximum point with this minimum point and draw a very nice sinusoidal function. So on the test, we'll be very, very clear with our wording. In fact, the wording will be very similar to what you have for question 3. So question 3, I'll just read the last part of it because the wording is perfect. And for question 3, it says the first maximum height occurs at 0.2 seconds and the first minimum height occurs at 0.6 seconds. So it's very clear. Okay, it's exactly one possible solution here. We're not going to get more than one answer or more than one possible graph. All right, so not much to say. 3D is interesting. 3D is interesting because you have first 4 moments. So I use coterminal angles, get my infinite solutions. And because I'm only looking for the first 4 moments, then I'm going to reject all the answers except for the first 4 moments. But I want to gather all the infinite answers using coterminal angles. So question 4, like I said earlier, same as question 2, I made that assumption. Because Megan could be rocking the chair a little faster, I'm not sure. But if this was on a test, I'd make the wording very, very clear how fast she's rocking. All right, so aside from that, there's not much to say about number 4. All right, so we have, let's see, question 5. So question 5, we have a paintball and a paintball mark, and it's going around and around and around in a circular motion. So the key thing you have to understand is that the period is the circumference. The period of the sinusoidal function is the circumference. Because for the paintball marking to return back to its original location, you need to travel, the wheel has to travel a circumference forward, or it can travel circumference backwards, or a multiple of the circumference. But you get the point. And I believe we did this a very similar question in the handout. So if you are unclear with this question, go back to the lesson, and I'm pretty sure there's like a nail stuck at the bottom of the wheel, something like that. Okay, so yeah, that's the hardest part to the question, and then from there, it's pretty straightforward. For 5D, coterminal angles, get your infinite solutions, but since the domain is restricted from 0 to 160 pi, then you have 4 solutions. And yeah, it says first 4 moments. So it's 160 pi because that's, we're looking at 2 periods, because first 4 moments will give me, that means I have to investigate the first 2 periods. And yeah, 4 solutions makes perfect sense. All right, so question 6. Nothing interesting about question 6. Very, very straightforward. Now, because you're looking at the second revolution, you're restricting t from values of 30 to 60. yeah, that's a little interesting, but just read the question carefully, because usually you're looking at the first revolution, but if you look at the second revolution, so you have to change your restriction. And for example, you look at the third revolution, you have to change it from 60 to 90. All right, question 7. So 7's a really nice question because you need to think about how long it will take to reach the bottom of the Ferris wheel. So if it takes 60 seconds to rotate 360 degrees, right? One full turn is 60 seconds, then how long will it take to rotate 70 degrees? So based on some proportional reasoning, you can solve for t, the time it takes to reach the minimum height, to be 35 over 3 seconds. And that will give me the horizontal translation. And lastly, we have, here we go. We have picking up a nail. So once again, just like question 5, the period is the, well, actually there's a little difference, sorry. This is time to travel the circumference. So we already talked about how the circumference is related to the period, but in this case, we want it in terms of as a function of time. So height of the nail as a function of time. So how long does it travel, how long does it take to travel the circumference? So that's basically like your speed formula. So speed is equal to distance over time. So if speed is distance over time, then time is distance over speed. So the distance is 50 pi centimeters, and change the 20 meters per second to 2,000 centimeters per second, because you want centimeters and centimeters. So then that means it takes pi over 40 seconds to travel 50 pi centimeters, which is the circumference. So that's the period. And then once you have the period, you solve for the k value. Bam, bam, bam. Find the equation of the sinusoidal function. And you can solve for the height after 15 minutes. Okay, so that's the solution for modeling periodic behavior homework.